Determine if the series converges or diverges. We have the sum from n equals 1 to infinity of 8n divided by the quantity n squared plus 4. Analyzing the formula for a sub n, the integral test is a good choice because the denominator is degree 2, the numerator is degree 1, and therefore we can integrate using substitution. To apply the integral test, we have a sub n equals f of n, which we then use to form the function f of x, where f of x must be continuous, positive, and decreasing on the interval from k to infinity. So once we know f of x and the interval, we integrate f of x from k to infinity. If the integral converges, so does the series. If the integral diverges, so does the series. Looking at the formula a sub n, notice f of x will be the function 8x divided by the quantity x squared plus 4. And now we need to determine the interval for which f of x is continuous, positive, and decreasing. Let's look at this graphically. On the right, we have the terms of the series graphed in red, and now let's graph the function f of x. Notice f of x is decreasing, not starting at x equals 1, but starting at x equals 2, and therefore we should use the interval from 2 to infinity for the interval of integration. However, if we think of this in terms of area, notice if we did start at x equals 1, it's not going to affect the result of whether the integral converges or diverges. But we'll go ahead and consider f of x on the interval from 2 to infinity, which means to apply the integral test, we have the integral from 2 to infinity of 8x divided by the quantity x squared plus 4 dx. Again, if we did integrate from 1 to infinity, it would not affect whether the improper integral converges or diverges. And now we'll perform substitution. We will let u equal the denominator of x squared plus 4, which indicates du equals 2x dx. Analyzing the integral, we know the denominator is u. We're left with 8x dx, and we have du equals 2x dx. Let's multiply both sides by 4, which gives us 4 du equals 8x dx. And now let's write the integral with respect to u. Remember, the 2 and the infinity are x values, not u values. We will leave the limits off for now. Again, the denominator is u, and 8x dx is 4 du, giving us 4 divided by u du. And now when x is 2, notice u is the square of 2 plus 4, which is 8. And as x approaches infinity, so does u. Because we have an improper integral, we now replace infinity with b and write this as the limit as b approaches infinity of the integral from 8 to b of 4 divided by u du. The antiderivative of 4 divided by u is 4 natural log absolute value of u, but because the values of u are always positive, we can leave off the absolute value and write this as the limit as b approaches infinity of 4 natural log u. And now we determine big F of b minus big F of 8. This gives us the limit as b approaches infinity of 4 natural log b minus 4 natural log 8. And now we determine the limit. As b approaches infinity, 4 natural log b gets larger and larger and also approaches infinity, which indicates the limit approaches infinity, which does not exist, which indicates the original series diverges by the integral test. I hope you found this helpful.